If you want to find out where something is concave down, you have to find points of inflections and check the intervals and see what your concavity is, and basically look for negative second derivatives, because concavity is the second derivative, and if it's down, it's negative. So what we do is you take the derivative of this, bam. Take the second derivative, bam. Now I want to know where this equals 0, because where it equals 0 would be your possible points of inflections, and then your concavity would change across those possibly. So we said this equal to 0, solving it for x, and you get plus or minus the square root of 1/2. Alright, that right there are my possible points of inflections. Alright, don't forget plus or minus. So up here, now I go up here and I go, okay, I put those on a number line, and I'm going to check values here, in the middle, and on the edge into the second derivative. Alright, so for this one, I plug in -1, because -1 is on this interval, nice easy number, and I put it into the second derivative. So I put it into this function right here, and it comes out to be 6, which is positive, so it means it's concave up. So on this interval, it's concave up, which we're looking for concave down, so that's not it. Now I plug in 0. Plug 0 into here, I get negative. That is concave down. Alright, so for this interval, it is concave down. And I plug in 1 to the second derivative. I get positive 6, concave up. So it's asking for concave down, so that would only be at 0, which is in between these two values. So where is it concave down? Between those 2 points. Those would be the intervals, or the only interval for which I am concave down. If you want to concave up, it'd be these two intervals. Okay, these are points of inflections, places where the concavity changes. So just remember, set your second derivative to 0, or where it does not exist, because points of inflections are where second derivative is 0 or does not exist. Solve them, make intervals, check to make sure they actually where they're changing, and put the intervals where they are negative for concave down. If it's concave up, the intervals for which the second derivative is positive.